In this video, we will try to look into the fundamentals of blockchain, with a particular focus on the blockchain structure, blocks, and their individual components. So what exactly is blockchain? Essentially, it's a digital ledger that records transactions and data, which is then shared across the network of computers. Here are some key features of the blockchain technology. Decentralization. There is no central authority controlling the blockchain network, making it difficult to censor or manipulate. Immutability. Once data is added to the blockchain, it cannot be altered, making it a trustworthy way to store information. Transparency. Anyone can view the blocks and transactions on the blockchain, making it challenging to hide illegal or fraudulent activity. Consensus mechanism. This helps prevent potentially fraudulent transactions from entering the blockchain by using decision-making process to ensure that the majority of the network agrees to the data's validity. Understanding of blockchain starts with its fundamental unit, blocks. These blocks are data structures within the blockchain database, serving as a repository for transactional data. Essentially, a blockchain is a linked sequence of interconnected blocks, each holding valuable information. To learn more about the block, we need to explore its components, starting with the blockchain header, an essential element of the block. Next, we have a block size. It tells how much data a block can hold, like transactions or other information in the blockchain. Next in line, the transaction counter, a crucial component for tracking the total number of transactions stored within the block. This feature provides an efficient way to identify the exact number of transactions present in a specific block. Finally, we come to the transactions themselves. This is the actual list of transactions that are included in the block. Each transaction represents a transfer of assets, information, or any other relevant data within the blockchain network. Again, as I said, the block header is one of the most important components of the block. It contains information like a block version number. Version number is useful in keeping track of changes and updates throughout the protocol. The hash of the previous block, the timestamp showing when block was made, the complexity level associated with mining, the nonce value, which is the random number used in the mining process, and the Merkle root, which is used to verify the integrity of a block. Now that we have gained an understanding of what is inside the blocks, let's learn about how these blocks are linked together. This connection is achieved through a unique cryptographic representation of block data. It is called hash. A cryptographic hash function is a math algorithm that takes any size input and produces a fixed size string of characters, known as a hash value. These hashes are usually deterministic, which means that the same input always generates the same hash output. Moreover, it is designed to be a one-way function, so it's practically impossible to reverse engineer the original input from the hash value. Hash functions are generally collision resistant, which means it is highly improbable to find two different inputs that produce the same hash output. Additionally, even a minor change in the input data results in a completely different hash value, making it highly sensitive to any modifications. This phenomenon is called the avalanche effect. Some of the commonly used cryptographic hash functions include SHA-256 and SHA-3 and many others. So, how blocks are chained together? Each block in the blockchain has its own block hash, serving as the unique identifier. To maintain the integrity and security of the chain, the hash of the previous block is incorporated into the header of each new block. This creates continuous and immutable chains of blocks, starting from the genesis block. Any attempt to modify the data in the block will result in the change of its hash value, which will also affect the hashes of all subsequent blocks. This makes it difficult to tamper with blockchain data, as any changes will be immediately detected. Therefore, every new block must use the hash of the previous block as its identifier. Now let's understand the fundamental characteristics of the block: block height, block size, and block time. Block height indicates the block's position in the blockchain and the overall length of the blockchain. The starting block, known as a genesis block, kicks off with the height of 0. Every subsequent block adds 1 to the height. For example, if the block has a block height of 5,000, it signifies that there is a 5,001 blocks in the chain, including the genesis block. The term block size refers to the maximum amount of information that can be stored in the single block. This measurement is typically in bytes or kilobytes and determines how many transactions can be processed in one block. The block size has a direct impact on the number of transactions that can be processed by a blockchain network. A larger block size can accommodate more transactions, which results in a higher overall network capacity and speed. However, larger blocks also require more computational resources to validate and process. On the other hand, smaller blocks use fewer resources but can process fewer transactions. Deciding on the ideal block size is therefore a balancing act. The term block time refers to the duration it takes to generate a new block within a blockchain system. The consensus mechanism implemented by the blockchain determines this duration. For instance, Bitcoin's block time is 10 minutes, while BNB Chain's block time is 3 seconds. The block time is a critical factor that affects the scalability of blockchain. Blockchain systems with longer block times are limited in the number of transactions they can process per second, since the network nodes require sufficient time to validate and add transactions to the block. To summarize, a blockchain is a digital ledger that is decentralized, transparent, and immutable. It uses blocks to store and record transactions or data. These blocks are connected through unique hash values, forming a secure and tamper-resistant chain of information. Thank you for joining us to learn more about blockchain. Our next video will be about blockchain networks and how they work. Stay tuned.